Okay, so we're down to the last couple of examples. So in this example 10, we want to use the elimination method. It says solve the system by the elimination method. Okay, I'm going to multiply the second row by 2. So I'm going to say this times 2 and this, like that. So then what that'll give us, I'll get x squared plus 2y equals 34. And then I'll get 2x squared minus 2y squared equals 14. When I add, these are going to cancel. I get 3x squared equals, that's 40, 44, 48. So then x squared equals 1 and 18, which is 6. So then x equals plus or minus 4. Okay. So then when x is negative 4, so we'll say when x is negative 4, then we'll get 16 minus y squared equals 7, minus y squared equals negative 9. So then y squared equals 9. So then y equals plus or minus 3. So then our ordered pairs end up being negative 4 comma negative 3, negative 4 comma 3, 4 comma negative 3, and 4 comma 3. So you would just want to check these in the original, okay? And you just want to check them, okay? And then for our last example, so it is well known that as the price of a product increases, the demand increases, and as the price increases, the supply increases. So the equilibrium point is an ordered pair x comma p, such that the number of units x and the price per unit p satisfy both the demand and supply equations. So in this example 11, we want to find the equilibrium point if the supply and demand functions for a new brand of DVRs are given by the system. Okay. So basically, we want to find where these two equations intersect. Now, I noticed that they're both already equal to p, so I'm going to try the substitution method. So if the first one equals p and the second one equals p, then we can go ahead and equate them to each other. So then we could say 60 plus 0.0012x. We want to equate that to 80 minus 0.0008x. Okay. So I would add the 0.008x to both sides, and I'll get 60 plus, I think that's 0.002x equals 80. Subtract the 60, 0.002x equals 20. X is going to be 20 divided by 0.002. Now we can move that decimal to the right 3 times in both. So we'll get 20, 1, 2, 3 divided by 2, which is 10,000 units. So then if at 10,000, then what that means, so then our P, if I take like the first one, we're going to say 60. The price is going to be minus 10.0012 times the 10,000, 1, 2, 3. And we'll get 60. We can move the decimal to the right 4 times. 1, 2, 3, 4. So it's going to be 60 minus 12. It's 50. That's $48 per unit. So about $50 per DVR. Is that right? Let's back that up. Oh, okay, I see where. I don't know where I got the minus. This is supposed to be plus. The thing that made me think it was wrong because I was looking at the graph. The x is 10,000 is correct, but I noticed it was closer to 70 and not 50. So I think I wrote the equation wrong. It's supposed to be a plus. So instead of that being plus, this is supposed to be $72 per DVR. So then the solution might be something like, so 10,000 units at $72 each. So that's the order pair. those are the coordinates of the equilibrium point between the supply and demand equation. So that actually concludes the semester. Uh-oh. Sorry, Siri. Thank you for your help. That concludes the semester. The device is just going haywire. It's been a great semester, gentlemen. I will see you tomorrow in class, or whenever you look at this. And our exam will be Wednesday. And have a good afternoon.